And you know what, I'm just add a couple more things and then everything just breaks. And you try to fix it.
Do you have someone here picking it up for you when it's
That's what
done?
happened.
Well, I asked Jenna if like when it was done, she could just grab it, or
Somehow that
I'll be back
was-
by 10,
You
so
have
I
to
don't know how long.
I'll be here.
Oh.
Okay, cool.
So
Yeah,
I
I'm
got
probably gonna be
one.
working on Internet anyway, so.
It's been fun pretending I know Python.
Let's see. Can I get a volunteer, anyone, to just go check the first floor and let anyone in? And as soon as they get back, we will kick off.
I can do it.
Thank you. In the meantime, I will check my email to see if anyone is desperately emailing me to say, let me in.
Wait, first or second? I'll just check both.
First, I said under the stairs, so first floor.
Okay.
That's what I think of as the main entrance.
Should cover this. Yeah. That's fine with 50%.
This class?
Yeah. Not a fan. I mean, it's
Oh,
also-
it lets you not care at all about homework. Isn't it great?
Yeah, that's the problem. Yeah.
Wait, how much
That
is
was
the
what I was
homework?
about to say, 25%. The midterm is also.
Yeah. But homework, you're allowed to like fuck up more times than you would in like midterm.
Right, but I definitely hit a point where I'm like, yeah, I don't understand.
As a midterm or?
No, the homework.
Oh yeah. That's true. That's when you harass this person and expletive answers out of his mouth.
Concepts. I explain concepts.
What is the answer? It's like shake him and then.
I love Steve's getting this on
It's
all
grabbing
recorded
off.
for himself.
Yep.
Steve be like, oh, glad I wasn't there for this.
I didn't know office hours were like a mafia shakedown.
Well, all of you are off camera, so unless they actually can identify by voice. Did everybody at least read all the problems in this? Okay.
Yes.
Like it's funny that like I haven't done problem 4. I mean homework A.
Mm-hmm.
Like so problem 4 didn't mean anything to me. I was like, okay, like I'm not doing it.
That one's gonna be fun.
Was it a difficult one?
If you know what you're doing, it's really quick.
It's like a problem 2 in the practice midterm. Cause I didn't even bother to look at it. Like I haven't done even homework. Like I don't know what I'm doing.
Welcome.
Can we have more office hours for homework 8?
Yes, Monday and Tuesday and maybe Wednesday, but I disappear on Thursday, so not Thursday, not Friday.
I'm still working on it for Thursday.
Welcome all. I will give you folks a chance to get stuff out, and then I will kick off. I figure by now everyone who's going to make it plausibly on time has made it, and everyone else isn't coming. So logistics-wise, the exam, the final is 3 hours, I think is the time slot. And it is 5 questions, so it's not quite twice as long test, but it's more than twice as long time. So you've got a lot more time. The expectation is that everyone should have gotten to the point where you can't do anything more on every question before time runs out. Right? That however time limited the midterm was, the final should not be. Other thing, grades-wise, Rock is very amorphous in terms of how he grades. He kind of sets the class in order and sees if there are natural breakpoints. And an exact calculation of score doesn't, it's not anything like 75% is a C. It's much more open than that. You could say he curves, but that would be making it sound much more systematic.
Does he just like blindfold himself and like throw darts?
No. He's got his own process. I am not privy to it. I tell him, everybody did all the homework. Y'all did okay at it for the most part. I send him the spreadsheet with homework scores. And he looks at midterm, he looks at final, he looks for improvement. He has all kinds of things he cares about in theory. You can ask him about his process, and he will tell you that it's much more precise than what I just laid out. Take none of what I just said as official, but also don't worry too much about your grades. You should be here to learn, right? All right, everyone's gotten stuff out. I'm going to kick off problem 1. I hope someone has a copy of the exam, because I actually don't.
Yeah.
Other than awesome. Problem 1, what does it ask?
Do you want me to read it to you, or?
Sure.
Okay. Consider the system below. It's a simple feedback loop that incorporates a bang-bang sensor. So the diagram is, yeah, and then there's a K and then a 1 over S in the forward loop.
Is this at all visible, or is this marker too dead?
It has room for improvement.
Is that better or worse?
Same.
Thank you. One over S, and then
And
our
then there's
NA.
an, yeah, sure, yeah. N of A equals 1 over A.
Yep. Right.
And then they ask you what's the frequency response of the system, Y out over YC.
Yep.
And YC is R cosine omega T with R equals 10.
Yep. So, we should all be familiar with this after watching last year's midterm, right? What are we doing? What kind of problem is this?
Describing function.
Yes, thank you. So A is our amplitude at the input to the nonlinearity. And this setup is actually a bit simpler than they had in the midterm because A is our Y output. So Y over Y command is forward gain K over S over 1 plus NA, right?
Mm-hmm.
And NA is just 1 over A, right? Something like that. If we want to know A, which is super useful to solve for, in order to know how big that is just Y is Y over Y command times Y, or times Y command. That, right? And we know magnitude Y command is 10, which makes this pretty easy to evaluate, right? Multiply through by S over K, something like that. So, 1 over A. Magnitude of this thing is omega squared over K squared, this thing, square root, omega squared over K squared plus 1 over A squared, something like that. Right? Let's see, square both sides. Something like that. I remember there being an easier way to do this algebraically. This should all work. But multiply through like that. Multiply through by a squared. Multiply through by 100. Multiply through by k squared. Yeah, that's a bit better. Still a mess. Getting better though. Yes. 99k squared equal to a squared omega squared. That's looking better. A. Something like that. That's a in terms of omega. Now we can plug that back into our transfer function to get y in terms of y command, right?
Dave, can you just explain why you get y? Why is a there?
Ah, a is the amplitude at the input to the nonlinearity,
Fair.
which is y.
Fair.
Yes.
Fair. Nice.
Good? Cool. So y over y command is going to be k over s over 1 plus k over s a. But now we have a in terms of k and omega. Still probably worth multiplying through by s over k first. No, let's multiply through by sa only. Right? K over sa plus k, something like that, if I did that right, before we plug in for a.
Yes.
Cool. Which is square root 99 k squared over omega divided by j omega times square root 99 k over omega plus k, right? When we do magnitude, magnitude y command is 10. So magnitude y, does it ask for magnitude
They
y?
asked for the ratio.
Oh, the ratio?
Y
Cool.
out over Y command.
Cool. So magnitude ratio is magnitude of this. That's scalar. This is a complex number. So we're going to get that squared, which is 99k squared plus k squared, something like that. As a denominator, this is and numerator is our same fixed square root 99 k squared over omega. Oh. Something like that for magnitude. And then the phase is going to be a constant because there is no omega dependence in the imaginary number, right? Oh, y over y command. negative angle of this thing. So imaginary part over real part. Square root 99. Something like that, I think. Can anybody work this out? And is it 80-something degrees? Like 84 degrees?
Yep.
Sweet. So that's that. Right? We got magnitude ratio, we got phase. Everybody's gonna nail ACE, the describing function question. If you find yourself stuck, not knowing what the heck to do, try to calculate the magnitude at the input to the nonlinearity in terms of other parameters, and then plug it in. That's generally going to get you through whatever has you stuck in terms of, oh, I have no idea what to do with A. It's all for A. Can I erase all of this? Any other questions on describing functions or this question?
Is that over 10K in the very far right corner?
This,
Yeah.
10K, and then it canceled with K squared. K over omega. Tenths K over omega. Yep. Cool. I even did that right. All right. Problem 2. You're given a system. Do you want me to draw it up, or do you not care?
I don't care, but.
That's fine. All right. We're also given a Bode plot for our linear system, and we're given an NA for our nonlinear system. So the thing that I always, actually, what kind of problem is this?
What's, yeah, Nichols.
Uh-huh. Yes, Nichols, finding limit cycles. I always recommend one thing on these problems to help keep yourself from getting confused. NA. Angle. Right? Big old table of values. And I'll sweep A from 0 to infinity. Right? Easy one to dispense with first. Angle of NA. What is it?
0.
Yep. Always?
Yep.
Yes. Always 0. So angle of -1 over NA, -180. Always. Magnitude. At 0.
0.
Thank you. At 1.
8 over 3.
Yeah, it's about 1. At 100.
About 1.01. Just kidding. No?
At
I
100?
mean, 100 times that. It's linear.
Yeah. O of 100. And at infinity, it's infinite. So these go in reverse order. Infinite O of 1, O of 1 over 100, and 0, right? Which means when we go to our nickels, our nonlinearity is just going straight up and down on that axis.
Dude, this O of 100, sorry, that just does represent, like, that was like, what are you saying, O of 100?
It's what? 8 times 100 over 3 pi, right?
Oh, I see.
8 over 3 pi is about 1
Right.
for the purposes of this table.
Okay.
When I start picking values out, I'll get more precise, but when I just want to know what does it do,
Yeah.
particularly when its phase is constant, yeah. If its phase had some change in it, then I might care about picking out values more precisely so that I can figure out where it goes. But if negative 1 over NA goes from infinite to 0 at constant phase,
Okay.
all I need to know is that it, has a value in between.
Okay.
So constant phase, debatably better. Going from low A to high A, right? And then we just have to translate our L into our nickels. So the L has a double integrator in it. It starts at infinite magnitude, and it does so at a phase somewhere just this side of minus 180, right? A little bit less negative. Then it's going to bump up positive, more positive, less negative, before it finally goes back down and settles somewhere over here. Right? How many limit cycles are there? That's the first thing you ask, right?
Yeah, there's one.
1. At what phase of L do we find this limit cycle?
Negative 1.
Yes, this should make it pretty easy to pick off the plot. Or to look at the transfer function for L.
It's really not easy to pick up.
Or to look at the transfer function.
First of all, you don't know where 180 is, right? But, no, please go on.
I have a question.
Shoot.
So that went up in gain phase because of the S plus 1, right?
Yeah. Yep.
How did you know it doesn't cross like negative 9? That doesn't matter, right?
So your total phase with your double integrator, oh, how do I know it doesn't cross minus 90?
Yeah, it's just approximate.
I just looked at the plot.
Oh, okay. All
I'm pretty sure it doesn't cross. It also truly doesn't matter.
right. Yeah, I'm just curious how you.
But in general, it's going to gain at most 90 degrees of phase from the 0, but it's going to lose phase from the double pole at 10,
Yeah.
and it's going to lose the phase soon enough to not have gotten, in fact, it can't cross 90 because it's only gaining 90 phase.
Right. Yeah.
So, yeah.
Makes sense.
So in the beginning, it's like asymptotically negative 180.
Yes.
I think that's
Which is
like second
technically an
problem.
intersection
'Cause
at
one.
0 amplitude.
It's 0 amplitude. So would it be counted as wrong answer if I say there is 2 limit cycle and one is a 0
One of
amplitude?
them is degenerate.
Sure, but it is, because I said 2 with the question mark and I, is it wrong?
If you explain that answer as, yes, there's a second intersection,
But it doesn't do
theoretic,
anything.
but it doesn't do anything, that's fine. We won't take points off for that. You also won't get any points if you can't find that one.
Sure.
All right, so one intersection, omega equals 10. And A, I don't remember what value I picked off. Oh, right. We want the output amplitude. I think I estimated it as A was like, or negative 1 over NA. This amplitude here was like 1 over 20, something like that, was my rough approximation. Something like that. Is that a plausible value, looking at the Bodhi? All right. Which is -1 over NA, magnitude from this is what? Over 8A, 3 pi over 8A. And from this, we should get A is about 25. I think I approximated 3 pi as 10 to do that.
Sorry, what was your estimated value?
1/20th.
Okay.
And you got omega again from your Bodhi that you did previously, right?
You're given the Bodhi in this one, but yes.
Oh, I see.
Yes. The other one, so to get the phase at -180, you've got the s squared s plus 10 squared. The point where this is going to drop, 90 degrees to be there is at the corner frequency. So it won't be quite exact, but it's going to be really close. A is 25. From that, we now need to do, oh, I do need the block diagram. Because we've got s plus 1, NA, and then s plus 10 squared. We've got this whole mess because A is here, and we want the amplitude here, right? There are two directions you can go. You can go back one element, or you can go forward 2 elements. They should give you the same answer, right? This is where it matters that we have our frequency. At frequency of 10, this is a gain of about 10, right? So if A is 25, that means this amplitude here is 2.5. And that amplitude is the amplitude of Y. So and I'm pretty sure when I worked it out earlier, when I went forward, I got the same answer. Was that a question?
Just on the s plus 1, you said there's a gain of 10 on that, you said? Roughly.
So s plus 1 evaluated at s equal to j omega,
Yeah.
with omega equal to 10.
Yeah.
That magnitude is approximately 10.
Okay.
So Rock in his solutions got a slightly different estimate. He got 2.35. Anything in that range, because we're picking it off of a Bodhi plot by hand, it's not super precise. If you really care, you solve it exactly. You use MATLAB. To the level of by hand, 2.5, 2.35. If you said 2 and you did it by justifying a number you picked off those plots, you're fine. By the time you're saying 1 or 5, we're starting to look at it and going, that's a little bit far off, but that's kind of the freedom you've got. Oh, right, last part. Is this limit cycle stable? Not last part, second to last part.
That's none of the parts.
Does it not ask if the
No.
limit cycle is stable?
Well, it asks what will y of t be doing
Yes.
t equals
Oh,
infinity, which
okay.
is the same
Yeah.
question.
Not quite. They're very related. So, sub part of answering the last question, is the limit cycle stable?
It was not.
I heard an answer.
It is stable.
Are you sure?
Yeah.
Are you really sure? What's the rule? If increasing A,
Oh, sorry, no, it's not stable.
yeah. Increasing A takes us inside the L curve. so it's unstable.
So weird how it's like inside the L curve, it's not really enclosed.
If you draw the Nyquist, you're gonna get,
And we get, the easy way is if you think the bottom is the bottom is the origin, like the infinite
Yeah.
the bottom is the origin, and then so if you shade everything to the right of the L curve, that's what's enclosed by L curve. So you don't have to draw the Nyquist then.
yeah,
The bottom right corner is the origin.
yes, the origin is 0 amplitude any phase, and that's,
Oh, it's not the bottom right corner, it's just the bottom.
yeah, it's the whole bottom.
Okay.
0 has no phase.
So how does that tell us what it's gonna do with the very small initial conditions? The limit cycle is
This-
stable.
Yes, so, this is not part of any requirement for this problem, but concept level. I'm gonna draw the phase plane for this system. Or for a system, an arbitrary system, with a limit cycle that is unstable. Right? There's some limit cycle here, but anywhere outside it blows up, anywhere inside it decays to the origin. That's what an unstable limit cycle is, right?
Is it always the origin or any equilibrium point?
To an equilibrium point.
Okay.
But from small initial conditions, we're gonna be inside that limit cycle, so we're gonna go away from it, which means we're gonna go to our equilibrium point. And on a linear system with a single nonlinear element like a odd quadratic, that's gonna be the origin. So it will go to the origin, in case that wasn't clear.
Would you need to, write out the system in terms of x doubled out and x and then figure out the equilibrium point?
If you need to do that to figure out what the equilibrium point is, do so. If you can look at it and go, this is a linear system, I think the equilibrium point's the origin.
Wait, can you explain how you actually went through that thought process? Because I have to think about x dot dot and all that stuff too. Like, do you think that-
For how I know the origin is the equilibrium point,
Yeah.
or for how I know
that, yeah.
Everything except your nonlinear element is linear.